All right. Let's say I was having a party and I was going to give everybody at the party 5 pumpkins. It's a pumpkin party. And plus, I need 10 pumpkins just for decoration. And I go to the store and I realize I can afford 72 pumpkins. The question is, how many people can I invite to the party? So usually something like this. X is people I invite. And for every person I invite this Y here, this X here, for whatever this X is, however many people I invite, I then have to multiply times 5 because each one of them is getting 5 pumpkins. And I have to add the 10 pumpkins that I'm decorating with. That's all the pumpkins. And all the pumpkins is equal 72. I can be 72 pumpkins. So how many people can I invite? Well, this is regular algebra. So we can figure it out. Minus 10 from both sides, so we're not worrying about those. I mean, we are worrying about them. We're removing their information from the equation. We're going to remove all the information from the equation except for the x. Okay, what about that? These 62 pumpkins need to be split up into 5 apiece. Well, let's divide by 5. 5 per person. Leaving us finally with persons. This color switching might be annoying. All right, 62 divided by 5. Come on, brain. You can do it. Okay, it's 12.4. So I can invite 12.4 people. Obviously, you can't invite 0.4 of a 0.4 of a person. So you can invite 12 people and you'll have a couple of pumpkins left over. And we can check our answer. Let's use the 12. 5 times 12 is x plus 10. 5 times 12 is 60 plus 10 is 70. And that is a little bit less than the original 72. So it'll take 70 pumpkins to have 12 people. I can invite 12 people. X is 12, basically. 12.4 technically, but in the real world, that wouldn't work. All right. Now, what happens when we have a different situation? What is this new situation, you say? I am building a tent. It's a square tent. All right. Here is the bird's eye view of my tent. I'm looking down on the tent. That is a terrible square. Let's try that again. That is a slightly better square. I will take it. Now, here's the secret. I don't want to put any of the important party pumpkins or anything, the sound equipment, the food table, or anybody's chair within 2 feet of the edge of the tent because it'll get rained on if it rains. So really, I have these boundaries that are these strips of 2 along the edges. These are all 2 feet 2 feet wide. They don't get included in the question. The question is, how wide can I make this? All right. Well, let's look at this width. This is the question I'm curious about. How much space will I have? How much space will I have for my party in this x by x square that's inside the bigger square? Well, let's look at the bigger square's dimensions. Along the top here, it's x and 2 and 2. So it's actually x and 4. Well, you could look at it like this. 2 plus x plus 2, which is x plus 4. That's one side times the other side. x plus 4 times x plus 4 equals all right, now here's the moment of truth. I know that my yard has so many square feet in the grass. So the tent, this whole big square that is x and 4 on one side, x on 4 on one side, and x and 4 on the other side, it cannot be bigger than 64 square feet. In fact, I want it to be exactly 64. The question is, what is x? How much room am I going to have inside the little square? And if we distribute this using our new skill, combine like terms in the middle, you might think, hey, isn't this just like the pumpkin problem? Can't we solve for x? Let's see. Let's subtract. Well, first we should check, can we combine these, x squared and x? No, they're different. Can we subtract x? I know. Let's divide by x. So if we divide by x, which, by the way, don't divide by x. But let's just pretend we are. You don't want to divide by x because you end up destroying some variable information, and you might accidentally be dividing by 0. It's just not a healthy behavior. But this is to show you what would happen. We would get x squared divided by x plus 8x divided by x plus 16 divided by x. Right? You know, when you're adding things and they all have the same denominator, you can just add them together with the same denominator. And 64 divided by x. Now, what is x squared divided by x? That would be x. Don't do that, but that would be x. That'd be 8. And then 16 over x, and then 64. Wait, this is a mess. Now I have x's in the denominators. This is a big mess. So you can't divide by x. That doesn't help. You can't subtract the x. Well, let me show you why you can't subtract the x. Let's subtract 8 x's. Sure, they would be gone from... Let me switch colors again. They would be gone from one side. Oh, x squared plus 16. Perfect. But now we have negative 8x on this side with the 64. This is a mess. The problem is the regular linear tools don't work for quadratics, for squares, for quads, for sides. It's not a line anymore. Now it's an area. And we have to develop new techniques. Fortunately, you already have one. The ZPP, the zero product property. We can use that to crack through factoring. You have to factor usually to use the ZPP. And what else can we use? We can use something called complete the square, which we might get to. So you make a square.
Daddy, ivy fight, too much ivy.
Okay, weed that ivy out.
But I want your help.
I'm working, buddy.
It does.
Are the electrons working on it?
A million.
Okay. One second, Allison. You can complete the square, and the last one is use a special formula that actually comes from completing the square. That'll be a fun formula to see. Okay, more in the next vid. Bye.